Woohoo! We are live. This is Math 60 Intermediate Algebra, and we're going to be solving quadratic inequalities. And so I've brought my Dancy friend here, have support, because these are, once we get practiced, hopefully it'll feel more comfortable. But I am going to have the sheet right next to us. I don't think I can fit it quite all into the same screen, but this lists the steps that we're going to go through to solve this. Now, how do we know we've got a quadratic inequality? Well, we've got x squared plus 4x is greater than or equal to 5. Since it's x squared, that's quadratic. Since it's greater than or equal to, it's an inequality. There you go. So first thing we have to do is we have to, in much the same way of dealing with quadratic equalities, I need to write this so that everything is on one side. Now, if I subtract 5 from both sides, I do not change the inequality sign, and I get a 0. You need a 0. Need a 0. Okay, so step 1, we want to look for the quadratic equation. So in this case, this one's going to be x squared plus 4x minus 5 equals 0. Notice that it's the equation, so I've got it equal to 0. And let's see if I can, again, factor this. There are a lot of ways you can do this. I'm going to go ahead and factor it because, again, it's not that difficult. I've got x and x, and then I think it's plus 5 and minus 1. I believe that's how it went. So then I've got x plus 5 equals 0, or x minus 1 equals 0. Right? I factor it, and then I split it up into the two possibilities, and then I solve each of these. And that will give me step 2, the critical values / numbers. Sorry, I got a little squished there. Okay, so step 2. Critical values / numbers. And those are x equals -5 and x equals 1. Okay, step 3, set up intervals and test. Okay, so I've got my number line. And my two numbers are -5 and 1. -5 and 1. Now, those are the places where it's equal to 0. So I got 0 there, 0 there, right? Those are my 2 points where I set it equal to 0. Okay, so I have to pick values in each of the intervals. There are 3 intervals here. And I'll go ahead and use pink, yellow, and green, and try not to take us to Smeary Town. Okay, so I'm going to pick any value I want between -5 and 1, and I want to pick 0. I like 0. 0 is usually easy to calculate. And so I go back up here and I calculate this new expression. X squared plus 4x minus 5. So that's going to be 0 squared plus 4 times 0 minus 5 equals -5. So it's negative. So right here, it's negative. Okay, I need a number bigger than 1. So I'm going to pick the number 2. You can pick anything you want. If you want to pick 1,000,000, that works too. X squared plus 4x minus 5. Let's test out 2. 2 squared plus 4 times 2 minus 5. That's 4 plus 8 minus 5 is 7. That's positive. Now, you could pretty much guess, if it's negative there and positive there, we would guess that this is probably positive. It doesn't always work that way, just so you know. It isn't always like a flip-floppy thing, like positive, negative, positive, negative. Sometimes there you can have two intervals right next to each other where it goes positive, positive, believe it or not. So we need to test everything. So in this one, I'm going to pick -6. -6, the quantity squared, plus 4 times -6 minus 5. Oh, this is looking like it's probably, I don't know. This is a good question. 36 minus 24 minus 5. That's 7. That's positive. Yay, positive. Okay, so I've got my intervals. I've got my positive versus negatives. I've got my zeros. So let's go up to the top and let's decide, what do we need it to equal? And I want it, so we've got a 0 over here. I want this big expression to be greater than or equal to 0. So I'm looking for positive and 0. Does that make sense? Greater than or equal to 0. Now, over here, what we were looking for in the original problem, we were looking for negative values. So we chose the spot in the middle where it's negative. This is positive and 0. So I want to pick these two sections. So step 4, this is going to be the solution. I want to choose the pink one. So that's from -infinity to -5. And then I want to think about this. Am I going to include the -5? And I'm going to say, yes, I am going to include the -5 because why? Because I am looking for positive values and 0. And at -5, it equals 0. Okay. And then I also want to pick this one. So again, I'm going to start at 1 with a bracket and go to infinity because I do want to include the 0. Now, we need a way to say, I want both of these. And the way we do that is the letter U. That stands for union. If you've got two pieces of interval and you want to glue them together, they jumped. So if we look at the graph, I've got the number -5. I've got the number 1. So we want to include all the way up to -5 and then jump over to 1 and then keep going. So we want the outsides, not the inside like the previous one was. And so I want those to be brackets because I want to include the zeros. Kind of woohoo. Hopefully your support staff is here, your support people, your support animals and Snuggies and all the rest. And maybe you have a support fruity drink or an apple. And hopefully that wasn't too terrible. That was it. We did it. Woohoo! Yay! Okay, now we're going to go and do something a little more exciting. Dun, dun, dun. And I'm going to regret this one because this one is admittedly a very hard problem. So perhaps I will regret it. The usual rule that I use is I should be willing to do some harder problems because if I only ever do the easier problems, then how do you ever learn to do the harder problems? You should watch me, cry. So if I start crying, you'll understand. This is important. So we've got an inequality, but this is not a quadratic. This is a rational expression. So we are going to do exactly the same thing we did before. We've got 9 over x is less than 8, and I'm going to subtract 8 from both sides. So that we get a 0 over here. Okay. Then I'm going to take these two and I'm going to combine them into a single expression. So instead of writing 8, I'm going to write 8x over x. 8 is equal to 8 over 1, which if I want to convert that to over x, I have to multiply by x in the numerator and the denominator, so I get 8x. The other way to write this is 9 minus 8x all over x is less than 0. Okay, so, well, that's exciting, isn't it? Woohoo! I know, everyone's like, oh, this is going to be fun. Okay, so step 1, convert it to an equation. So I've got 9 minus 8x all over x equals 0. So let's talk about a few things. What sort of things could we talk about? Well, we could talk about the fact that we've got an x in the denominator. So right off the bat, x cannot equal 0. So that's really important. We got to remember that. And then the next thing to note is that if I have a fraction or a rational expression equal to 0, then I know the numerator has to equal 0. Put another note over here. If a over b equals 0, then a must equal 0. The numerator has to equal 0. There's nothing you can do to the denominator to make a fraction equal 0. So the rule is, if you got a fraction equal to 0, you got to make sure a equals 0. So we make this note. I got notes all over the place here. And then also I say 9 minus 8x equals 0. Okay. So then I add 8x to both sides. 9 equals 8x. Divide both sides by 8. 9/8 equals x. So far, so good? So the interesting thing is, I got some paper right here. I think we got it. There we go. Okay. So how do I get these both in the picture? So an interesting thing is, by critical numbers, which is what the book calls them, or values, which is what I learned to call them, basically the same thing, are going to be x equals 9/8, absolutely, but then also x equals 0. Now, why x equals 0? Well, that's a critical value. That is a value that x cannot take on. You cannot let x equal 0, so we're going to have to look at that. Okay, so that's step 2. Step 3. Set up the intervals. Nine-eighths is just a little bit over 1. So that would be about 1 would be somewhere in here. I'm going to look at values from each of these. Now, for this, you've got a couple of options how you note this. 9/8, the whole thing equals 0, right? So this is a 0, but it doesn't equal 0 here. It actually, and I always learn to do a U for undefined. But you could do something else. You could put an X or a no, or maybe use a color red and say not allowed, or stop sign, or whatever you want to do. This chart is for you. I got to pick some values. I'm going to pick 2 here. I'm going to pick 1 here, and I'm probably going to pick -1 here. Let's see if those are good choices. Let's go back to the problem. Now, our expression that we're looking for is this 9 minus 8x over x. So 9 minus 8 times 2 all over 2. 9 minus 8 times 2 over 2 is 9 minus 16 over 2, which is -7/2, which is negative. Okay. Here in the middle, 9 minus 8 times 1 all over 1 is going to be 9 minus 8 over 1, which is 1 over 1, which is 1, which is positive. And let's look at this third part of the interval at -1. 9 minus 8 times -1 all over -1. Okay, so it's going to be 9 plus 8 all over -1. And that's 17 over -1, which is -17. So something interesting happened. Even though this is not a 0, 0 does not create a 0, 0 is undefined, it still split from negative to positive. So that's kind of interesting. So our 3 intervals, we got the pink part. Wow, I'm just living in Smurry Town now, aren't I? So let's look at the original problem. We had 9 minus 8x all over x is less than 0, right from there. So this is what we want. Okay, those are the points we're looking for. We want it to be less than 0. So we want negative. So where were the negative answers? The negative answers were here. Do I want to include 9/8? And the answer is no, because I don't want it to be equal to 0, so 9/8 is not included. Do I want to let it be equal to 0? No, that's right out, because it'll blow up the whole thing, so we don't include that. So I want, maybe this time I'll do the graph first. If there's 0 and there's 9/8, I'm going to do a parenthesis, and I'm going to go to the right here because I plugged in 2 and that gave me a negative number. And I'm going to do a parenthesis here and move to the left. And so that's -infinity up to 0, parenthesis, not bracket, 9/8 to infinity with parentheses. And then in the middle, remember, if we're going to put them together, we want a union. There we go. And that was, sorry, I forgot to write, that's step 4. Step 3, step 4. Woohoo! Was that fun? Is that so much fun you want to do it one more time? Well, wow, have I got a deal for you. Dun, dun, dun! Take a deep breath. Bring in your support family, get something nice to drink. Make sure you're comfortable. We can totally do this. We can handle this. Okay, so to be worried when we've got a situation where we've combined everybody. So everybody's come together. Everybody's working together to thwart us. But there is the saving grace is we don't have to subtract anything. We don't have to make anything. We are allowed to just work with this here. So we can start right off the bat with what we learned before. And we could say, okay, right off the bat, x should not be 4, right? Because it's in the denominator. And if it were in the denominator and it were equal to 4, then we would have 0, and that's no good. So x is not equal to 4, which means 4 is one of our critical values. Okay, next we have to set up the equality. And you'll remember that we already noted that x is not equal to 4. So if we're looking at a fraction or a rational expression equal to 0, then we know that we need the numerator equal to 0. Okay, then I'm going to try to factor this. Let me see, does it factor? Kind of looks like it, doesn't it? Looks like this would be plus 2 and minus 1. Does that work? Plus 2, 4, plus... So negative 2 would be 4 minus 2 minus 2. Positive 1 would be... Yes, sorry, I was a little slow there. Double checking my work. You ever in the middle of a math problem and it just doesn't look right? Yep. And I want to catch that quickly so I don't confuse anyone. Okay, so my two values are negative 2 and 1. Those are critical values. But so is that, the restriction. So if there's a restriction on the domain, if there's a problem with the denominator, that is also a critical value. So in this case, we actually have 3. That's why this one's a little bit exciting. Okay, and what are we looking for? We're looking for, we want positive, right, and 0. Okay, so let's set up our chart. That's a little exaggerated, but it'll give us room. So we want 4, negative 2, and 1. So there's negative 2, there's 1, there's 4. Now at 4, it's undefined. At 1, the whole thing equals 0. And at negative 2, the whole thing equals 0. So let's test it in each of these other spots. So this is going to be where I test 0, because that's between 1 and 4. I'm going to test 2. From 4 to forever, I'm going to test 5. And from negative 3 down, I'm actually going to test negative 4. I'm dealing with fractions, so I want to try to keep them even. I don't know if that's going to be helpful or not, but I'm hopeful. Okay, so where should we start? I'll start over here. Why not? I'm going to test this. So I'm going to test 5 squared plus 5 minus 2 all over 5 minus 4. Now, some people would actually test these. There's a sneaky way to do this. I'm not showing you that way right now. But there is a shortcut. So if you're interested, come talk to me and say, is there a shortcut? Because I would love to use the shortcut. And I would say, absolutely, there's a shortcut. And in fact, you could go and you could say 5, that's positive, that's positive. That's positive, you're done. But let's see, 25 plus 5 minus 2 all over 1 is, I think that's 28 over 1. That's positive. Yay! Okay, so that's that section. And so 2 squared plus 2 minus 2 all over 2 minus 4. It's equal to 4 plus 2 minus 2 all over negative 2. So that's 4 over negative 2 is negative 2. This is negative. Okay. 0. 0 squared plus 0 minus 2 all over 0 minus 4. 0 plus 0 minus 2 all over negative 4. That's negative 2 over negative 4. That's positive 1/2. Ooh, that's positive. Okay, and the last one. Negative 4, the quantity squared, plus negative 4 minus 2 all over negative 4 minus 4. And that's going to be 16 minus 4 minus 2 all over -8. 12, 10 over -8. That's negative. Okay, so let's look at all of these. Come back up here. We want greater than or equal to 0. So we want a positive or 0. So positive or 0 means I'm looking at these two spots. I like positive. Positive is good. And I like 0. So these two, right? Because those are zeros. Am I going to include 4? The answer is no, I'm not. So let's see. Step 1. I forget what the steps were. This is steps 2 and 3. And then here is step 4. Let me write this, put this here so you can actually see what's going on. We want positive and 0. So on our line, are we going to include -2? And the answer is absolutely. -2 is included. Oh no, Smearyland. Are we going to include 1? 1, 0, 1. Here's 1. And the answer, it's equal to 0? Yes. Notice I'm being much more careful with my number line. The reason for that is once I've got 3 points on it, I should really graph them properly. 2, 3, 4. Should I include 4? And the answer is no. That's where it's undefined. That's where everything explodes. It blows up. X cannot be 4. So I'm not going to include that. Okay, so I'm going to include these 2 points. And I'm going to include this interval. And I'm also going to include this interval. Okay, so this is going to be bracket and parenthesis. Kind of interesting. So I'm going to include -2 to 1 inclusive, and from 4 to infinity exclusive, and I put a union in the middle. What do you guys think? Can't be 4, can be 1, can be -2. Woohoo! If you made it through, you guys are awesome. Good luck on the homework. Thanks for making it through yet another video. It's a dance party time now. Anyway, have a great day. Have a great math life and math on. Woohoo.